All of our videos here are brought to you by the Landscape Certified Contractors Association. Due to the membership support, we're able to bring these videos to you each and every week. If you'd like to be part of our organization and help us bring these videos to you, make sure you visit www.irrigatortech.com and have a great day. Done this before here at the show. So I read the description and they said I'm going to go over what we need to know out of the USC textbook, a little bit about backflow, and then testing procedures. That's why I brought my gauge here. Is anybody a tester, certified backflow tester? Okay. No? One? Okay. So I won't necessarily cover that, I guess, as much. We'll go more of a practical aspect of this. Anybody have experience with backflows? No? Opening them up? They leak, right? Yeah, okay, so I'm going to go over how they operate, why we need them, some terminology so you can kind of be in the know, because there's a lot of terminology. To become a certified tester, you need to go through our program, and we follow the USC textbook. So there is a lot of terms. There's a lot of terms that you need to know and understand so we can kind of move forward, and they'll make a lot more sense. So anything anybody wants me to cover specifically, like before I start, so I could kind of gear towards that? No? No? We're all just hanging out today after lunch? Good? Okay. So no specific backflow questions? Maybe when we get to it. Okay, so I'm going to go over terms and definitions. Our class is from 1 o'clock to 2:30, right? You're going to stop me? 2:30? You're just hungry, huh? Yeah. I don't blame you. But I'm hungry too. Okay, so studying for the backflow certification, it is the USC textbook, the 10th edition. The book is $100, $105 maybe. You can buy it through our school, when you go to take the test, or you can go get it online anywhere. And kind of a funny story, I just did this class not too long ago, and a student came in and was like, "Man, why are you trying to charge me that much? I got it for $20 on Amazon." I was like, "Oh, really? Oh, that's cool, right?" And he brought it. It was the 5th edition, right? We're on the 10th, right? Just recently, about 4 years ago, I'd say, we went from the 9th to the 10th. So periodically, they're gonna change because they found a better way to do it. It's a lot of procedural things, the way that we test it, and the readings that we're looking for. They're always trying to improve. So. Okay, so with that being said, So with that being said, does anybody know why we have a backflow? Does anybody know why? Why?
So the water doesn't get sucked back into the general kind of
the potable water system? Yeah.
Water system.
Yeah, that's basically, in a nutshell, it keeps polluted water, right? Water that goes into the consumer system through the meter, keeps that water from coming back, right? He explained one way that the water goes. There's actually 2 ways that the water can be reversed, and we'll go over that. So basically, yeah, so this is our only protection against contaminating our drinking water, right? So they're not just the shiny things sticking up there for someone to steal, right? Although it happens, right?
It happens.
More than we want to admit, right? So a backflow keeps the water, so that's pretty important, right? So when we have people that are not certified, that are not coming and testing these things, we don't know if they're failing, right? So possibly we can have contamination getting into our drinking water, right? If you go take the course, you need to know how it comes down the chain of command. So it starts with the EPA. So the EPA, sets the drinking water standard, says it can only have this much, does all the microbiology tests, all the parasites, bacteria, all this stuff has a certain level. Then it goes down to the state health department, and then from the state it goes to the local to the local health department, and then it goes to the water purveyor. So the water purveyor is the one who delivers the water, right? So the water purveyor makes sure that every year, so every backflow that you see, once a year it needs to be certified by a tester, right? Just like your car tags, right? It's going to send you paperwork, and you got to get it tested, right? So you can see, every time we connect to drinking water, there needs to be a backflow. So you can see why one person in here knows there's a lot of revenue that can be generated, right? Think about how many buildings there are. Every building has a backflow, right? At least one. I'll go over, there are some that are inside buildings, and I'll go over that. So they're very important. It's the only way we can have safe drinking water. So in other countries that don't have safe drinking water, I know China is trying to implement safe drinking water like that. Well, the only way to do that is to put backflows in there, right? On every single connection. So you can see, that's why I'm considering moving to China, right? That's a lot of money, right? Make some money, come back, right? Any questions on that? Does that make more sense why we have backflows? Right? Pretty important. Right, and so our irrigation systems, is everyone here pretty much irrigation driven? Pretty much landscaping, yeah. So they consider our irrigation systems high hazards. Why do you think that is? Why would our irrigation system be a high hazard, potentially?
Land exposed.
Yeah, we throw what? Fertilizer, right? Pesticides. Like you said, if something sucks that back, well, if the sprinklers and we just threw a bunch of fertilizer, it could pull back in through the sprinklers, right? Very small possibility, right? But it's a possibility, right? Was anybody aware? This is my test kit right here for certification, right? Normally it doesn't look like this, right? But this is the 4 different types of backflows. Were we aware there was 4 types? Not really, right? Irrigation, we deal with a pressure vacuum breaker and an RP, right? Reduced pressure principle. So I'm going to go over those, but the ones where it leaks out the bottom all the time that we see, right? That's an RP. So these 2 right here, actually. So have we seen these in the field? Not much, right? But we see them. There's a reason for that. We'll go over. And then we see these, right? That's a Febco, the brand, but there's Wilkins, Watts. This is a Wilkins here. Like this one right here, right? Leak at the bottom. There's a reason for that. We'll go over that. Has anyone ever seen one like this? Starting to see these more? Yeah. So there's plastic in there, right? So it's cheaper. A little bit of anti-theft. Pass that around. Anti-theft, they go in there. Can't scrap plastic. You can, but it's not worth anything. A little funny story. One of my students was from city of Huntington Beach, and they got this row of 7 for a park, right? 7 backflows. They were getting stolen. They were stolen 4 times in 2 years, right? All 7 of them. They put cages on. They pulled the cages off, right? Everything. So they found out about these right here, put those in, and then same thing, water wasn't running. They came back, and the guy broke the plastic with a hammer and left a note, put in something better, It's like, wow, like, why don't you have security cameras or something? I mean, something's wrong here, right? So they're starting to think about different things that will deter somebody from stealing something, right? I think they're actually, I haven't looked at their booth, but I think they have, instead of the brass, like sidings like that, I think it's stainless now. Right? Something different, right? A little bit cheaper for them to recycle. I don't know. USC, again, is like pretty much like the ambassador of backflow, cross-connection controls. So to get a backflow to be approved and okayed by them, it's a 2-year process. I think it's somewhere like $80,000, $100,000, something like that. So if a backflow is approved on their list, you can go and check out. Pretty much anything we get at a distributor is approved. Right? They're not going to sell anything that's not approved. But so that one, even though it is a plastic body, it did go through the approval process. So some newer things out there. Right? So there's 4 types of backflows again. I'm going to try to squeeze it in and cover a little bit about each one. Each one has their own specific place and time, right? So the term backflow, so what is the term backflow? So we call these backflows, but these are actually backflow prevention devices, right? So they stop it. So a backflow is the undesirable reversal in the flow of water. So we hit on that earlier, right? So somehow the water is going back, and we don't want it to go back. There's 2 ways that happens. So there's back pressure and back siphonage. Okay, so those are the 2 issues that gets the water to reverse. So this is pretty important. So we need to know if these 2 conditions can occur, it's going to determine a different backflow that we're going to put in, one of the 4. So I'm going to cover back siphonage first. We kind of touched that. The gentleman in the corner said that it sucks back. So that's what you want to think of as a siphonage. A siphonage would be the water supply on the city side drops pressure, right? So when that drops pressure, it's going to pull water backwards. Does that make sense? How could that happen? What would cause the city main pressure to drop? Any ideas?
Breaking main.
Yeah, of course, right? City main would break, right? Is anyone in LA County there? No? Okay. Well, you see they have all these issues, right, of these main lines breaking. Well, that's going to suck water back from every area, you know? Another more common than a mainline break is going to be a fire engine. So the fire engine hooks up to the fire hydrant and they start sucking the water out, right? So if they have a building that's on fire, they're out there with the hoses and the fire's getting larger, they're going to pump that pump up, right? The whole backside of that fire engine is a huge pump. So that pump's just going to pull that water. It's going to start within a mile. It's going to pull back water from every meter, right? Backflow is going to stop that. So all 4 of these backflows, all the different types, every single one that I have up here, and this little guy right here, they'll protect against a back siphonage. Because every single backflow can, because that's the city side, right? You have no control over that. So every backflow protects against back siphonage. Any questions on that? No? All right, so that's just the city side. Just think of the city side dropping, and then that's going to pull water. Has anybody siphoned anything? Gas? You know, we're out there, you need gas for your tools or whatever, right? You create a vacuum, and then you have to hold it down. If you hold it up, then the water, then it won't siphon, right? So the second issue that we run into is back pressure. So this is when it gets not tricky, but this is when it's more selective. Not every single system can have back pressure. So back pressure would be when the consumer side, so our side of the water, increases the pressure, and the pressure increases higher than the pressure coming in. So now the thing about water is water always goes from a high pressure to low pressure, right? It always wants to force its way back, right? So it would be something in our system would be increase the pressure higher than the water pressure coming in, and it would just follow its way back into the public system. So any ideas how that could happen? How could our consumer side, the pressure increase? Let's think about irrigation. We have a pump system, right? We have a pump system that kicks on, say we have a master valve, or we have some kind of malfunction and increases the pressure, well then it would overpower and go back. Also elevation. So if I have a sloped area, I mean we all water slopes, right? When the water turns off, the water wants to come back, right? That would cause an increase in pressure. That can cause a backflow to happen. Okay. So the 2 types, back siphonage and back pressure. Okay. And then the term cross connection. So cross connection is any time that we're connected to potable water. Anytime we're connected to drinking water, that's a cross connection. Right, so here's a little. Okay. Right, so this is showing us some siphonage, reverse flow caused by a loss in pressure from the supply line. So here's my water supply, should be going this way. For some reason I lose pressure, it pushes the water back. Back pressure is when our system side's increased. In this case, we're at 80 psi, and our inlet pressure is 60. The water is just going to force its way back. Any questions on that? Potable water. Anybody know what potable water is? Drinking water? Yeah, safe water, right? Safe drinking water. So, what were the two ways water can be reversed? What were those two words? Back siphonage and back pressure, right? Now, the other two determinations on which backflow we can install, one of the four, is going to be whether I have a pollutant or I have a contaminant, right? So a pollutant, so we're talking about our consumer side. So a pollutant is something that'll change the aesthetic quality of the water, right? It'll change the taste, but if we drink it, we're not going to get sick, right? So the most common, like for the certification, the most common question they're going to ask you is if, you had a edible syrup, so say like a soda machine, right? So every big soda machine, where you go and select it, every one of those have a backflow, right? Because there's a pump in there, right? It's directly plumbed into the line for the whole entire building, and it's edible syrup. So can I get sick from drinking that? No, long term, right? We're all listening to the news, right? Don't drink soda, blah, blah, blah. No, but initially it's not going to make you sick, right? So that would be considered a pollutant. Contaminant, well, that's something that's going to make you sick. So you can think of a pollutant as a low hazard and a contaminant as a high hazard, right? So for irrigation, we're looking at a contaminant, right? So we get that fertilizer, that pesticide, anything like that, when we drink it, we can get sick, right? And then thirdly, the lethal hazard. A lethal hazard is radioactive water or raw sewage is what we're looking at. And in those cases, we would need an air gap. An air gap is a physical separation. We don't want to have it straight plumbed into any backflow, just for the risk, nothing else. All right, so pollutant, contaminant.
So those backflows that they're using on the soda machines, they were made by the state too, so they had to be tested every year?
Well, yes.
Why?
But see, okay, so
Everybody tested your incoming water to
yeah.
your building.
So, right. So that goes a little bit deeper. So we have containment protection and isolation protection. So containment is at the meter, right? That's the water purveyor, right? Because they want to protect their assets. They want to say, hey, I want to make sure my drinking water is good. That's a containment. Now, the water authority, the water purveyor, they're sending out the notices. They want that tested. Now, once it goes through it, they don't care. They're like, hey, that's not my water anymore. That's their water. They bought it. It's gone through the backflow. I know it's not coming back. So then inside, internally, it goes to the local health department to be.
So that's the state,
So
and
there's-
the city, and
Yeah.
the county?
I mean, sometimes you'll run into a county implemented water district, right? So like Irvine Ranch Water District or whatever, they have their own internally, right? So it's still county, but when you run into big corporations, like your Subways, your Starbucks, all these big places like that, yeah, they do it, right? 'Cause they don't want to get
Someone's
attacked. Yeah, exactly, right? So all someone's got to do is go wash their hands and like wash their face, and there's some kind of soda, sticky something gets in their eye or something, Smaller places, maybe not. Whenever they get inspected, inspector, from the health inspector is going to say, where's your backflow? You know, you have to keep your test reports for 3 years, right? Every year needs to go, and the tester and the property owner have to keep their certifications for 3 years.
So
So,
we're in the state of Arizona, and Arizona don't have that, implement that yet, so.
yeah,
No,
for the isolation protection?
For the soil machine.
Yeah, the internal, yeah.
We have some internal backflows, but
Right.
it's not a requirement to test it.
And it's low hazard, right? So
Yeah.
they think, oh, you know, we can let it slip. Now, if you have like,
Well, we use it on the bars and then we use it on
Yeah.
the reservoir, like the ice machines.
correct, you know, like autoclaves, you know, if you're going into like laboratory equipment or it's toxic stuff, yeah, you know, then that they're more up on. And then again, it's just, it's kind of a different deal. Water purveyor does containment protection, and then once it goes past that, it's more of the local health trying to do that. Some more of the definitions. So how can it happen? How can backflow happen again? What were the two ways? Back pressure and a back siphonage, right? Either way, it's the unwanted reversal, the flow of water coming back into our system. So the different types of backflows that we're going to kind of cover. Again, this is to become a certified tester. It's a 40-hour class, so we're just going to do our best to kind of just cover a little bit. Atmospheric vacuum breaker. So that's considered a backflow device, not a backflow assembly, because there's no test cocks on it, right? So these are test cocks. We hook our tester up to these. The atmospheric vacuum breaker does not have any. Right, so does anybody know what an atmospheric vacuum breaker is or it looks like? Right? I see an anti-siphon valve. The little float in there that goes up and down. That's an atmospheric vacuum breaker. So when the water stops moving and inside the unit it reaches the atmospheric pressure, and it just drops down. And it allows air in, right? The only way to stop a siphon, right, because every single cross connection, there's a possibility of a siphon, and it's to emit air into the system, right? So open up to atmosphere, the siphon pulls air, it stops. So a good example of that is if we have a straw, right, and there's a crack in the straw. You ever cracked your straw on accident and tried to use it? It's kind of hard, right? Because you're pulling air, you're not able to create that vacuum. Not be able to create that cycle. Reduced pressure principle, right? This one here. This one's unique because it has 2 check valves, right? So 2 eternally loaded check valves. These are check valves here. So these are inside, these chambers here. So it has 2 of them, and it has a relief valve. So the RP has the highest form of protection out of the 4 backflows.
So that's what you use on like on the hazardous stuff.
Absolutely. There's 2 that we can use on hazards, right? Because there's 2 that we see in irrigation. So we kind of gauge our irrigation because it's high hazard. So the pressure vacuum breakers, also the RPs, right? So me, when I was learning this, I'm like, well, why? If I have one that does everything, the RP, then why don't we just put the RP everywhere, right? It's the best. Well, there's different issues that deal with it. I mean, the cost is high, right? It discharges. So do I want this inside a building? Not necessarily. You can, right? It has to be plumbed directly, and you have to go to the building code, and they got to come and do all that. So there's certain types of reasons that we don't want to do that. And if we don't have, the situation that we need an RP, we can go something easier, something cheaper. But that was my question. Like, well, if the RP is the greatest, then why not only use that? So there are some drawbacks to it, but it does provide the highest form of protection. And we'll go over why. The double check. So we were talking about soda machines, right? A little double check, right? They do a little 5/8 one. So here's a double check. It has 2 check valves, like what you guys are passing around, but it doesn't have that relief valve, so it doesn't dump water out, right? We have a pressure vacuum breaker, which one we have up here? Pressure vacuum breaker. And we have a spill resistant vacuum breaker. So this is the same, except it doesn't spill. Okay. So we would see that medical fills, things like that. Depends on, one, the degree of hazard. So if I have a high hazard, a contaminant, or a low hazard of pollutant, and if I have back pressure or back sound. So does anyone here install backflows? If we needed to? Has anyone ever installed one? Yeah, right? What do? Just put whatever was there, right?
I tried to mash it over.
Yeah, if it was like right here, if it was this Febco, would you just put the Febco back in?
Probably,
Or I guess you might not know, right? You might just see 2 sticks up in the air, right? You're like, I don't know what was in between there, but I'm sure it was a backflow.
It's easy to replace it with the same.
Right, like for like, right? The best thing to do, is call the authority having jurisdiction. So whether that be the water authority or the city or whoever, and ask them, because they do have preferences. I know when I do testing, I see a lot of the paperwork, especially in like Anaheim or in Orange County, it'll say if you need to replace it, like if I can't get it to pass, it needs to be replace a pressure vacuum breaker with an RP. That's what they say, right? They said, get rid of those, just let me put an RP. Okay. That's their prerogative, right? We don't care. We're going to put something in regardless. We just make a little more money because there's more market. Right? What do we care? Right?
Is that a recycled?
Yeah. Well, usually when they painted them purple, it was plumbed to be domestic, and then I've tested one that was like that. I told them they don't need it. It's non-drinkable water going into non-drinkable water, right? Recycled claim we don't need to test, but they wanted to test.
That's why I was questioning you about the test.
Right. Right. Okay, another important thing to note, especially being a contractor, having a C27 contractor's license, it does give you the ability to install a backflow. I mean, you have to learn it. You're doing a construction job, quote unquote, right? But you have to have it certified after installation by a certified tester. Now, I would say, just from my experience, I'd say like 90–95% of them don't get certified, right, after new installation. I've gone on sites and I went to go, they give you the paperwork, they're going to give you serial number, model type, what it is, and I go there and I'm looking for one and it's all brand new and something else. Not a huge deal, right? I'm still going to go there and certify it, but as a contractor, being a certified tester, I mean, that's just another $75 you could tag on, saying that it needs to be certified, because it does. You can go on, there's legalities, there's paperwork, there's things that you can back yourself up and show the client and say it needs to be certified. Because just because it's brand new doesn't mean that it's good, right? You could, with using pipe dope, people use too much pipe dope. It's not water soluble, it's just going to stay, it's going to clump in that check valve like they're passing around, and then it won't seal. And I'll go to test it and it won't pass. Do they need to rip it out? No, they don't have to rip it out, but I got to open it up and clean it, flush it out. So that's how they get around it. Because it's really strange to me. I know I have my chemical applicator's license. To buy certain chemicals, I need that license, right? They say, let me see your license, and they do all that stuff. For backflow, any homeowner can go buy backflow, install it. Well, hey, that's my drinking water, I think that's more dangerous to abuse than a chemical, unless they're maliciously using that chemical, right? But the way they get around it, and I've searched the USC textbook because everyone always asks me, well, don't you have to be a certified repair technician to repair the backflows? And there's nothing in there that doesn't say that, because they don't have they don't have that license yet. You know, the way they get around it is, like I said, every time we install one, we need to get it recertified. Anytime we open it up, how many people have opened up a backflow that's leaking? It's more of us than that, right? Not just, I've done it
We
before,
do
right?
that.
Of course, right? It's like it's leaking. Oh no, it's a diaphragm. It's never, I wouldn't say never. 99% of the time, it's the first check valve. And I'll go over why on RP, but you open it up to atmosphere, you open up the check valves and take things apart, moving parts, it needs to be certified again. So there's a lot of work out there for backflows, and it's really needed. That's why I always encourage people to do backflow certification, even if you never know and you never use it, at least you have knowledge on it. I'm going to try to cover as much. I'm going to kind of focus on this RP here, because I know this is what we see, because based on the room, we're irrigation landscapers. We see this because of the protection that it provides. So, I'm going too fast. It's a lot of information. Okay, so the RP. So the reason why the RP is able to protect against the highest of the hazards, except for the lethal, right, those two connections, is because it can protect against back siphonage, right, and it better, right, because every backflow needs to. Every backflow is going to protect against that. And it also protects against back pressure. So in the book, the textbook, it identifies a unit that is able to protect against back pressure as having 2 check valves. And I was like, okay, why? Right? I always ask why, because I want to know. And it basically just says if one fails, there's another one to back it up, right? I was thinking of I was hoping for a better answer, but it makes sense, right? So there's only 2 that can protect against back pressure. Now there's the RP, like I said, because it has 2 check valves in it, correct? And the double check, right? Because in the name, right, it has 2 check valves. Right? So pressure vacuum breaker that we see in irrigation, it only has 1 check valve, so it can't protect against back pressure. Right? So if we have this and we have a pump, we need to take this out. It's against code. Right? If we have this, and the people that have seen this, have they noticed it's kind of high usually, sticking up out of the ground a little bit? Well, it needs to be a foot higher than any downstream piping, any sprinklers, any pipes, anything. It needs to be a foot higher to give it a little bit of pressure difference. I'll cover that again. So that one doesn't protect against back pressure. So the RP protects against both. And now it protects against any hazard except for a lethal hazard, right? Yes?
What part of the RP it has to be 12 inches above?
Good question. So the RP is 12 inches above grade, right? Finished grade, so that's the key finished, right? And that's going to be the vent of the discharge, right?
That's the one that had to be 12.
Of 12 to 36. So if you go a little bit higher, 18 inches, you're good. You're in the clear, right? And that's because we don't want it to be submerged, ever. Because if it's submerged, then it's considered a cross connection, right? Because the water system is connected. Because unprotected water is actually on the backside of the diaphragm with no check valve or anything. It's our high side pressure. Right? And that's another thing, it's installed above grade. Now the double check, because it does not discharge, it just has the 2 check valves, you can install it below grade, right? Or in a building or something like that, right? And so another important thing to remember, for a backflow to protect against a high hazard, contaminant, high hazard, it needs to, what we call vent to atmosphere. So basically means it dumps water out, right? So whatever that contamination is, and it's coming back, it's going to be able to dump it out. So the RP does that, right? It does it well. We see it all the time, right? Whether we want it to drip or not, sometimes it drips, right? The pressure vacuum breaker, yeah, that one does too, right? Comes down, the water will expel if it's getting pulled back. So if it does that, then it can protect against the high hazard.
Sorry, question.
Mhm.
When it's dripping out, does that mean the backflow, something's wrong with it, or is it just, it's doing its job?
Depends.
Yeah, okay,
I'll answer
okay, first.
that after the break.
Okay.
No, okay, so yeah, exactly. And that's always the issue, right? So it's doing its job to a certain degree, right? So the reduced pressure principle. So without really knowing it, they're cluing us into how it operates. Okay, so reduced pressure principle. So how does it keep water from reversing? Well, it uses the reduction in pressure, right? Reduced pressure, right? So we're going through this taking a step back, when I was talking about backflow, water always goes from high pressure to low pressure, right? Yes? It doesn't ever go from low up through high pressure, right? Always goes with the path of least resistance. So with my RP, water's coming in this way. So with an RP, it's always indicated that the test cock, so these that stick out here, is always before the number one shutoff valve. It's a troubleshooting deal, right? So you can tell the direction of the flow without looking. There's an arrow here on the back side, but it's 1, 2, 3, 4. So it's always on the outside of that one, so you know that my water meter's here. Okay? So the way this works, and it's specific, it's a very specific thing because that's what we're testing for, my gauge. So my gauge, this is what I certify backflows with. It's a differential pressure gauge. I just taught class the other day. So this gauge is going to tell me what the difference is between 2 points, right, of connection. So it's going to tell me what my pressure is before and after this first check valve. So this first check valve in the RP is the most important one, most important component. Yeah, the relief valve keeps the contamination, but the number one check valve is the regulator. And it's going to regulate the pressure to a drop of a minimum of 5 psi. Okay, so that's one thing that we look for, right? Because in the name, it's going to reduce the pressure. So if I have my meter coming in before and I have, say, 100 psi, that first check valve better drop at 5 psi, right? So you can think about it like you have 100 guys trying to get in. It's going to take 5 of them to hold it up to let 95 through, right? And then it's going to close those other 5 out. So now the water's not going to go backwards, right? So like I said in the beginning, 99% of the time, it's our number one check valve is not being able to hold back enough, right? Another thing I test for certification is that this relief valve, where the water actually discharges from, opens up when the pressure gets within 2 psi of being the same. So for some reason, this check valve's not dropping me 5, it's dropping me like 2, and I'm at 98. Well, this is going to dump a little bit because it always keeps that, what we call buffer. So if it's dripping out continuously, 99% of the time there's just some dirt in there. Depending on the amount of discharge, depends on how much of a leak it has. If it's just a little drop, then just a little leak. You know, it's like there's maximum capacity is 100 people, right? You push one person in, another one drops out, right? That's what it's doing. So theoretically, yes, right? So there is some troubleshooting you can do, right? Armed with a screwdriver. Does everyone have a screwdriver in their truck? Hopefully, right? You just jam it up in there and just start. No, okay, so what we're going to do is you're going to open up the number 4 test cock and the number 3 test cock, right? So on the after the first check valve. Now, if we do that and the relief valve stops discharging, then there's a problem with the number 1 check valve. Okay? And so what we're doing is, I always think of it like 2 lines, right? Before and after the check valve. And if it's too close, well, I'm going to get discharged. Well, if I open up downstream while I'm dropping that pressure, so it should seal up momentarily, right? It should seal up. And then you go, oh, okay, well, I just have a dirty test cock. Dirty check valve. Now, if you do that and you still have the same discharge, and you open these 3 and 4 up all the way and it's spraying water and it's still discharging the same, well, there's going to be a problem with the relief valve or the way the water travels into the relief valve or something like that. So that's a little trick. So it could be that. Most of the time it'll stop leaking a little bit, and you can either open up the 2 and the 1, close these two, open the 2 and 1, and it'll discharge, because I'm dropping the inlet to get that to jump. And sometimes it'll flush out, especially in a new install, it'll start leaking.
Yeah, he had a little seal in front of the relief valve. Sometimes when that one seal is broken, it's just getting leaking all the time.
Yeah. Right. And so there's three components. Well, there are 3 components, but there's 3 seals. There's the check valve 1, right, where that comes down and seals, right? Then we have where that relief valve, where Jim in the back is talking about. So that needs a seal. And then also the second check valve. But so the thing with the second check valve, it doesn't fail that much because it needs to just hold against back pressure. Right? So if the water's coming backwards, it just needs a seal. That's its job. Right? But the number 1, that's the regulator one. It needs to drop that pressure to keep that gap so we don't have discharge. Right? So if it's leaking continuously, what can I do with my screwdriver? Shove it in there and start to wear. I mean, no joke. I came to one and I was testing it and I was going to get it to open and it was supposed to be leaking out. I'm like, what's going on? I filled there. Someone had epoxy coated it, sealed it up because it was leaking. It's like, oh my god.
Screws.
Yeah. You seen screws in there? Yeah.
I've seen a guy actually go up and using a screwdriver.
Pry in there.
This is the way guy told me to do it. He's shoving it in there and I'm going, get it
That
away
was-
from
that
the
was-
back.
That was probably one of my earlier students before I realized that was stupid thing. Because I mean, I was even under the impression when we see something leaking like that, what do we think it is? First thing we think of, diaphragm, right? Right, because we're irrigation guys, you know? We're like, oh, the valve's leaking, it's the diaphragm. But a lot of times, I mean, if you have a pressure gauge, you know, just like a standard one that goes to test sprinkler heads, you can put it on the 2, open it up, read your pressure, close it, go to the 3. If they're too close, it's going to discharge. That's just what's going to happen, right? The other issue that it leaks without anyone touching it would be what we call intermittent, right? So it would leak and then stop, right? And we walk away, you know. Happened to me before. I put a new one in, and it just leaked and it stopped. I'm like, walking away, and it'll leak again, and it's like, whoa, what's going on? So what happens in that situation is the city pressure is varying, right? Because 95%, so like 20 hours out of the day, well, here in California, Southern California, 5 days out of the week, the water's off, right? So everything's closed. So on a RP, my check valve 1 and 2, they're biased, so meaning they always want to stay closed, right? The spring's pushing them closed. But the relief valve, it's always trying to open, right? It's the 2 to 2 psi tension. It's always wanting to open. Now we have high side pressure on the back of that diaphragm, closing it, keeping it closed from leaking, but it wants to be open, right? So everything's just sitting there. So if it's all closed, I get pressure to drop. Well, now the high pressure on the backside of my diaphragm is too weak and it opens up. And then once it resets, it seals itself back up, the pressure drops again, and then now I got higher pressure downstream, it opens up the relief valve and it dumps. So it's all just a play on pressure. It's like a big teeter-totter, right? Dump, dump, right? Just keeping the water from coming back. Any questions on that? It's kind of a lot. Just wants to keeps a drop in pressure and it keeps the water from reversing. We learn anything about the RP? Maybe a little bit? No? Okay. After lunch? All right, so again, you asked that question. Well, where is that from? Well, it's the installation. We need to have that air separation, so an air gap of a minimum of 1 foot, 12 inches, from the relief valve discharge. Right? It's because we don't want it to ever become covered with standing water. I used to work for a company. We did maintenance for a local city, and I was looking for the backflows. We just took over. I'm trying to assess the situation, the job, find where the controllers are and everything. And I'm looking for backflows. I'm like, where are they? Like, oh, they're over here. They show me they're in valve boxes. They're completely full of water. I was like, oh my god. I said, well, they got stolen all the time, so we put them in the ground. They make cages. Right? So again, so for terminology, so when we're looking at the RP, we have test cocks, right? 1, 2, 3, 4. And those are just for testing purposes, right? They're not for filling up your spray tank, even though we see it happen all the time, right? Fertilizer sprayer, we fill it up. Car wash, whatever. It's not for that. Right? We have the water flow coming in this way. So we know that because the first test cock is on the first shutoff valve, right? So I can be able to shut this off, but there still be a way to check and see if there's water. We have 2 ball valves, shutoff valves. We have 1 and 2. Now the thing about this, do you think it's mandatory to have the handles on there? No? Yes? No? Yes, it actually is. It is. It has to be up to code. It has to have the handles on that. In case of an emergency, it's got to be able to be shut off. Yeah.
I keep following a man that likes to take off that first test cock. I don't know why someone would do that. Have you ever, I've come across now 4 backflows that this guy has done where he's taken off and put a different a shut-off valve on the first that doesn't have the first test cock.
Really? No. There's actually a troubleshooting issue that we run into.
If you had to bypass.
Yeah. If our number two shutoff valve was leaking with downstream demand, we would have to connect the 1 to the 4 to close the second check valve to be able to build the zone to dump. It's kind of a lot. That's all you use it for.
Well, and the authority told me to go ahead as long as the backflow passed, that they would go ahead and accept it as long as and like you say, the only time you need it is if you need bypass.
Yes.
So they allowed them to stay in there, but I don't know why this guy did it. There's like 4 of them that he took off the first test.
And the shutoff valves are the same manufacturer and everything?
Yeah, you can get them without the test cock.
Yeah. It would just be the second one. And
You
it would
just
spin
put
on.
the second one back on there and got rid of the first.
No, I've never heard that.
That was very bizarre.
Yeah.
So if you're certified backflows and the handles are not on there, are you able to certify the backflows to take over again?
Yes. But you're supposed to put handles on before you leave the premise. You know what I mean? So you would just put some on. It has to be the same. So Wilkins, you have to put the Wilkins.
Yeah.
Or I mean, what I learned, kind of the hard way, is just to write as many notes as possible on your test form before you turn it in. When I arrived, it didn't have handles on it. It didn't do this because I ran into an issue. I was doing the fire sprinkler system, and the packing seal on the second shutoff valve, the big one, was leaking. And then by the time I closed it and opened it back, it was coming out good. And I tried to seal it, and I told the property management lady, she was on site, and I told her, hey, look, this is leaking. It was all mossy, so it wasn't just me doing it, right? So it's been doing it for a while, but it's really bad now. You need to get that fixed and stuff. She's like, oh, I'll have my guy take care of it. I said, okay. What am I going to say? So I didn't say anything. But on that job, there was a new RP installed for the irrigation system that was not reported. So I wrote all that information. So the water authority went there. And when they went there, they saw the leaking, and they called me. Said, hey, this is leaking. What are you going to do about it? And I said, I don't know. I tried to I was going to have one of my buddies do it that knows how to do it. But they didn't want to do it. And he says, well, you know, you need to write that down and write down the lady's name and her phone number because they want to get that taken care of. These fire sprinkler lines are actually not metered, right? There's no water meter there. So they'll have a little bypass backflow with a meter on it to catch low flow. So any water that's leaking out, that's free water, basically, right? So they want to stop that. So we should stop any leak, but that's not always possible. But yeah, I would just make note of that. You know, and you say, hey, I tried to charge them for that, you know, and they didn't want it. Just tell them, hey, I got to put them on, and you take them off after I'm gone. That's not my business, but, you know, take pictures, send pictures in with your reports. I mean, as far as the water purveyor is concerned, we're out there. We're their eyes, and we're their ears, and we're their pulse, right? Because they have one guy usually, or two or three, trying to take care of a whole county, right? Every single backflow, that's not viable, right? That's not something that's going to be able to happen. So that's why they have testers, and that's why we have to go to the county and show them that we prove ourselves that we can actually do the test, right? So we go and just tell them, send pictures and stuff like that. If they like you, that's just going to be more work for you in the long run. So here's a breakdown. My least favorite, a Watts. Watts isn't here, is it?
Yeah, this guy's with Watts over here.
I am.
He's like, nice to meet you, Jack Watts.
I work at Kellogg's.
Yeah. I just say that because the check valves are in the body here. So if there's a dirty first check valve, which happens a lot, I got to disassemble the relief valve. I got to pull this whole thing apart to get to that check valve. Not my favorite.
Getting the line back up can be difficult.
Exactly. Yeah. There's like a little space. That spacer retainer cage is not friendly. Right? So here's our relief valve. So our discharge would be down here at the bottom, and I got my test cocks 1, 2, 3, 4. Right. So even though they look all different, the good thing about learning backflows and learning these certifications is an RP is an RP is an RP. If it's 3/4 inch, it's 8 inch, 12 inch, right? These big ones, it's all the same. Same moving components. Of course, repairing is a lot more difficult. But as far as certification, where you're looking for the same exact things, right? First check valve drops at 5 psi, or drops 5 psi minimum. The relief valve opens when it comes within 2 psi of being the same, and the number 2 check holds a back pressure. That's all that we're looking for, no matter what. We just play dumb and say the bigger ones are harder, so we make more money, right? So, oh no, I don't know, that one's pretty big. Another thing we want to do is when we install it, we need to have proper clearance. I have my test cocks on the front side here. I can't have the wall right here, right? You have to move it back. It's a minimum of 18 inches. It's better to do 2 feet and 1 foot on the handles. Give it room. And so I asked the question because when we have a cage on it, sometimes the cage just barely fits on it, but we gotta move the cage, right, to test, so it doesn't really count. All right, so that's the reduced pressure backflow assembly. Any questions on that?
One other question.
Yeah.
Is there a requirement that we double union or just one union? And it'd be easier to have 2 unions on it. Or
Yeah, easier to steal.
Well, that's it, yeah. But
No, you know what? It really depends on who's in charge, right? That's the authority. I mean, pressure regulators, we see on there a lot, right? We see pressure regulators. Sometimes you see them before, rarely, but sometimes you see them before, sometimes you see them after. Theoretically, in a perfect world, we would want them on the inlet because that's just a lower pressure going through the assembly, increases the longevity of the device, right? Because there's not a lot of high pressure banging on it. But some water authorities don't want you to do it. Some won't even let you do anything. You have to have straight pipe coming in. So it's best to ask. Yeah. Mhm. Even Y strainers, I mean, most of the time they don't care, but sometimes they don't let you put a Y strainer because you could tap something into that Y strainer, right? And you could pump it through. So,
See the irrigation system attached,
the whole system.
the whole system attached.
Just a quick story kind of regarding that a little bit is I did this class up in Northern California for a water district, and one of the gentlemen, he sits on the board for the Homeland Security for the water, and he said they did their own little investigation, well, I guess investigation, shenanigans, whatever you want to say. They had a big truck, right, water truck, and they hooked up straight to a fire hydrant, right, in the middle to see if anybody would say anything, because you're not allowed to do that, right? It's a straight connection into a system, right? Nobody said anything. So then they came back the next day to another, like, metropolitan area, dressed like the quote-unquote terrorist, right? To see, doing the whole dog and pony act. Nobody said anything. So they went to a residential, same thing. The only time anyone ever said something was a police officer stopped and said, "Is everything okay?" And they said, "Yeah, everything's fine." And then they just kept going because they were going home. It was on this way home. So, I mean, yeah, people don't know. Irrigation system pumped in right there. If there's any kind of a siphon, it's going to pull everything, right? If that truck had a pump in it, even just from the elevation, it's going to push the water back in. They could have been pumping all kinds of bad things into our water. He also said they found people with plans and ricin and all kinds of like really, really bad, poisons pumping into our system. They have done it before, but it dilutes it so much. Dilutes it so much that we don't get sick. That's the good thing in water. It's a solvent, right? Greatest solvent ever. So if you were to get into testing, I know that pretty much only a couple people are testers. Again, this is our kit. To test the RP, you need to have our hose, the 3 hoses, high side, low side, and bypass. This is Midwest. There's multiple manufacturers out there, but this is like middle of the road tester. Is there any other? How much time I got? I got like
23 minutes.
23.
You're 45 minutes over.
Is there any, before, this is all testing, I don't really see the need to go over it entirely. For the RP, is there anything else on the RP? Any other questions? And that was a lot, right? Did we realize that there was that much going on with these things? No, right? We were like, okay, let's call somebody to verify that it's certified. Okay. So the second one that we're going to talk about, and probably the last 3 we're just going to kind of graze over, is a pressure vacuum breaker. So you see it has only one check valve down here. It has the poppet, which is what goes up and down and seals. And we have the upper bonnet here. So only one check valve, meaning it can only protect against back siphonage, not back pressure. As far as troubleshooting on these, the only thing we would visibly see, right, the only thing we can see is that this air inlet, the poppet and the bonnet where they meet together, the seal's leaking, right? It's the only troubleshooting thing. And in that case, we would just close the first shutoff valve, close the second shutoff valve, open our test cocks to bleed the water out, and just open it up, right, and see. It could be tear, it could be worn out. Especially this model, right? Because what does that look like it's made out of? Brass. And it's held on by a screw. A nut. So one nut holding that on, those dishes are gone all the time, right? And then we all know that plastic and light don't really mix very well, so it corrodes it, makes it brittle, and it leaks. In that case, we would just open it up and replace those components. Now, we wouldn't know if the check valve is failing on this unless we test it. So as far as a repair technician, we would just see if it's leaking. Again, they're being phased out all the time. Irrigation, they just say, hey, you know, if that's not going to pass or it's leaking and it's not going to seal, just replace it with an RP, just get it done, right? And that's when we go to the water authority and then we just get them to back us. Okay, so this protects against only back siphonage again, right? Because why? Huh?
One check.
One check, exactly, right? There's not two check valves. How high does it need to be above the downstream piping?
12 inches.
12 inches, right? Minimum, right? So if you had like a little medium slope, would it be okay if, you know, you put it up 8 feet? Guess so, right? You put like a squirrel box on it or something, you know, feed some animals. But no, I mean, it would be more, it would be a lot better if we would put an RP in there. Because it doesn't care, it can do back pressure all day long, right? So that's what we're getting at. We need to be 12 inches higher than the downstream piping because we can't have any pressure coming back. And can it protect against a high hazard? Yeah. Because it dumps, right? Because that air inlet drops and it just has to dump. Right? So the water has to fly out of the unit in case of the water being reversed. So the RP and the pressure vacuum breaker, we're good to go on toxic, high hazards. But the pressure vacuum breaker's limiting factor is back pressure. Back pressure. Back siphonage. Just quickly. Atmospheric vacuum breakers, or anti-siphon valves, we also call them. They are not testable. They're only required to be 6 inches above the outlet, the water outlet, so any downstream piping. The limiting factor, the main limiting factor is it can only be under pressure for 12 hours in a 24-hour period, right? These are the ones that just have the flow, right? We'll see them on slopes when it runs out the laterals, or we'll see them on an anti-siphon valve for a residential property, right?
Why more than 12? Why is 12 hours a big deal?
You know,
They say it's sealed.
yeah. I mean, it's because it's not testable, so they're not even sure if it's working. So just limit the amount. I think they had to put a number, and they said, well, if it's running half of the day. Yeah.
So people don't use just RP because it's expensive, and in some cases, it's kind of an overkill
Yes.
measure
Yep.
for what the application is.
Yeah. Yeah, so you're like, hey, if I'm running a medium strip, well, we can't water medium strips anymore, but you know, back in the day when we could, you'll see these pressure vacuum breakers a lot because it's like, oh, it's got this little area of flat land, and they have a point of connection on almost every single island. Having an RP is just a lot of money to do that. Yeah, that's one of the things. We can't have any pumps with an atmospheric vacuum breaker. We can't have any downstream shutoff valves. It's another one. Because if we have a shutoff valve downstream, then that's going to continuously have pressure in the unit, and it can't be under pressure for more than 12 hours. That's why we have our valve, then the vacuum breaker, right, on the residential valves. There we go, 12 inches. there's not a whole lot to it, the troubleshooting. So even when I do the certification class, I mean, it's a lot of RP, man. It's the most difficult to test, right? It's got the most hoses that we use. It has the most amount of steps, has the most amount of issues that can happen to it to make it discharge. So this pressure vacuum breaker, all it's going to do is when the water gets siphoned, the check valve here at the bottom of the body is going to close, and then the air vent's going to come down and pull air in and stop the siphon, and then water's going to come out. Right? Pretty basic. So for testing, we need our kit, and then a bleed-off valve arrangement, which compensates for leaking of a shut-off valve. These are just the steps. Okay, then we run into a double check. So the double check just has 2 check valves in it. So can it protect against back pressure? Yes, right, because that's 2. So we're good for back pressure. And does it dump out? No, there's no vent for it to dump out, so it can't protect against a high hazard, only low hazard. Okay? So the majority of the fire sprinkler units, so every building has to have, commercial building, and they're getting into the commercial now in some areas, is they have to have fire sprinklers. Those are protected by a double check majority of the time. Unless they have black iron piping, which they would want an RP for that. I don't know if anybody has tested one of those. I have. It's disgusting. I wouldn't want to drink that water. It smells. Because it's sitting stagnant in there for a year, right? Until someone comes and tests it, but it never fully cleans itself out. So again, back pressure, but not high hazard, only low hazard. So you'll see these internally a lot, as long as the hazard's low enough. Another benefit of the double check is that it can be vertical. Right? Any other backflow cannot. So is there anything that can leak on the double check? No, because everything's sealed, right? Things like on these larger sizes, like I said, the packing seal, which is here because of the open stem yoke shutoff valves, those will leak. You would just have to tear them apart and repack them and reseal them. Other than that, they don't leak. So that's a benefit. Unless you got to take, pull flanges off or something like that. So relatively low maintenance. And it can be installed below grade.
When you say below grade, what about water getting around the test box? I mean, can you totally bury it? If somebody's messing around with the test box and then they get the test box partially open and the thing's buried down in the dirt?
Yeah, but that could be, I guess, with any backflow tampering. I think as far as like act of God, as they call it, like if a flood comes or something like that, it's able to keep water from reversing. I'm sure that's part of the USC testing. I'm sure they do underwater or something like that, I would assume. But that's a good question. All right, so this is going to be a foot above grade. All right, it can be submerged. Typically, we'll see it above grade. In areas where it freezes, they allow you to put double checks in for irrigation, and they'll just put them below. All right, so we just see here, we just got 2 check valves. So these are independently working check valves. They don't work together, not like the RP. So for testing, that makes it a lot easier. You just test one, and then you do the same exact test for the second. And they don't drop a lot of pressure. The maximum pressure drop through a double check is 10 psi. we'll drop 10 psi on a, you know, any day through an RP. Again, low hazard. Just cover the last one. So the final one is the spill-resistant pressure vacuum breaker. Okay, so it's the same as the other pressure vacuum breaker. It could be under pressure for more than 12 hours, right? It can be under continuous pressure. The only difference is that it doesn't spill out. So it works a little differently. On the pressure vacuum breaker, the water comes up, pushes up the check valve, then seals the air inlet, right? And then water passes through. On the spill resistant, the water comes up, seals the air inlet, because there's a diaphragm here at the bottom, then it pushes the check valve up and water passes through. So on this one, the check valve will shut, then the air inlet will close. That's how it keeps from spilling out.
So that's like an indoor application.
One restriction is it can't be any toxic fumes, right? Because it would be open to atmosphere and the fumes would be coming out, but there would be no spillage, so no one would have any warning signs. A lot of the medical fields I've heard, I've never tested one out in the field. But yeah, that's where a lot of them are. Somewhere where it's just like, you know, like an X-ray machine. I heard they have them a lot because, you know, where they develop them, they just put it up a foot higher because there's no back pressure because it's open atmosphere. It's not closed. So issues like that. So for troubleshooting on this, as far as a repair technician, if it's leaking, same thing, just shut the test box down, take off the top, clean it out, see if you can fix it, put it back together, see what happens. And then you need to call someone, right? Because you open it up. Anytime we open up a backflow, it needs to get certified. Right, back siphonage only, not back pressure, because it only has one check valve. So it gets a little iffy on the toxic and non-toxic liquids with this one. Through that USC textbook that we teach our certification out of, I teach for the testing, is the outside of the book, right? Chapter 1, 3, 9, and a little bit sprinkled in the middle. There's also another certification you can get from that. It's called Cross Connection Control Specialist. Sounds cool, right? That's like the title right there, right? What they do is they determine if it's a high hazard, low hazard, if there's back pressure. So they go and do a complete survey of the system, and they're the ones who determine what backflow put in. Right? So you would really rely on them with the spill resistant to know if it has toxic or non-toxic liquids and if they can put that in. Because we're not able to change as a contractor, even as a tester, we're not able to change, you know, the level of protection. We can only go up. We can go from a PVB up to an RP, but we couldn't go from an RP to a PVB. Does that make sense? We can always go a little bit more if we want. But from my experience, just call the water authority, water district, whoever has control of the backflow, and say, hey, this is the situation. What do you want me to do? I just recently there was a double check down in a vault in the street in Anaheim. I went to test. It didn't pass. We couldn't get it to pass. It needed to be replaced. And I just referred it to someone else because the city wanted it to be raised up out of the vault, you know, be up above ground. It was right next to the street. You had to close down the street, and that's not something that I wanted to get my hands in. But without calling them, someone would have just replaced it right there, and then the city could have just came in to inspect it and said, no, I want it to be higher, and then they would have to come back and do it again. It's always best just to call. Yeah.
A temporary backflow prevented for construction area. Like we had to do one side here and every time you change from meter to
It's
meter.
relocated, yeah.
That's the best.
Yeah. You're talking about the little, you
Yeah,
plug in the RP right there and then you get the hose out of it?
Yeah, but we had to move the backflow, the RP, we had to move it from
Yeah.
1 meter to another.
Yeah. Needs to be certified.
It had to be tested every time we moved.
Just because when, it could be anything, could get in there, you're putting it in, it's like you're reinstalling it, right?
Yeah, that's what we do, we should
Mhm.
move from
Yep,
one side to another side.
yep. I mean, you could call the water authority and ask them. I'm sure they're gonna say,
Well,
yeah.
I wonder if this is required,
Yeah.
because we had to test it every time we move.
Mm-hmm.
It costs money every time we move.
Yeah. And that's pretty much it. Any questions?
Do you have copies of this presentation, hard copies? Is it on the website or?
No, not really. I mean, I'm gonna put it on YouTube. I have a bunch on our YouTube channel. I have a lot of. Yeah. A lot of videos. You guys can follow us. Our certifications or. I do a lot of the backflow stuff on our YouTube channel. So you can go watch videos or email us saying you want a video on something. But yeah, they don't have me bring anything for you guys.
And the few certificates, you have to buy all the
Equipment,
equipment, all the equipment.
to go test for the county, you have to bring equipment. And that kit right there with everything, with all the hoses, the attachments and everything, it runs about $1,200. But we test like 20 backflows, pays for itself. Less than most people. Just like anything. Is there any other questions anybody has?